Have you ever stopped to think about the invisible force that powers literally everything? I mean, the thing that gets you out of bed, cooks your food, and is powering the device you're watching this on right now? Well, that's energy. And today, we're going to follow its incredible story through a day in your life.
So here's our game plan. First, we'll nail down what energy even is. Then, we'll track it from your breakfast table out into the world. We'll get into the energy of motion, see how we power the whole planet, and then we'll wrap it all up with why this stuff is so important for our future.
Okay, first things first. Before we can start following energy around, we've got to ask the most fundamental question of all. What is this stuff, really?
Seriously, just take a second to think about it. The light from your screen, the sound in your ears, all of it needs energy. But where's it coming from? It's not just the wall outlet. It's this whole chain reaction of transformations that's actually way more amazing than you'd think. So, at its core, the textbook definition is pretty simple. Energy is just the ability to do work. But the part you really need to remember, the absolute golden rule, is that it transforms. It changes form, but it's never created or destroyed. That one idea is the key to, well, everything. All right, let's bring this down to earth. We're going to start our day right from the moment you wake up and trace the first few energy handoffs you encounter before you even walk out the door. And our whole story kicks off with breakfast. See, the food you eat is jam-packed with something called chemical energy. You can think of it as potential energy, just locked away inside the tiny bonds holding all the atoms and molecules of your food together. And right away, your body performs its first magic trick of the day. As you digest, you're breaking those chemical bonds, releasing all that stored up energy. And what do you do with it? You turn it into mechanical energy so you can move around, and thermal energy to keep your body at the perfect temperature. You're basically a walking, talking, energy conversion machine. Speaking of temperature, what about cooking that breakfast? Well, for that, you needed thermal energy. It's just the fancy term for heat. It's the energy that gets molecules all jiggling and moving faster, which, makes things hotter. So if you used a gas stove, you were witnessing a classic energy conversion. The natural gas has chemical energy stored inside it. When you light the burner, you're converting that stored energy into useful thermal energy to cook your eggs. It's another transformation happening right there in your kitchen. And of course, your house is just buzzing with other types of energy. You've got electrical energy flowing through the wires, sound energy coming from your speakers, and even invisible magnetic energy humming away inside motors. And they're all playing together, all the time. A ceiling fan is the perfect example of this teamwork. You flip a switch, and electrical energy zips into the motor. Inside, magnetic energy helps turn that electrical flow into good old mechanical energy, the actual spinning of the blades. One form becomes another, all to give you a nice, cool breeze. And what's really cool is how this is a two-way street. When you talk into a microphone, you're doing the exact opposite of a fan or a speaker. The sound energy from your voice, those vibrations in the air, gets converted into an electrical signal. See? It's all about conversion. Okay, breakfast is done, the fan is off, time to get moving. Now we're going to look at the physics that governs everything that gets from point A to point B, whether it's a simple pendulum or you driving to work. So when we talk about motion, it really comes down to two sides of the same coin. You've got kinetic energy, that's the energy of doing something, of being in motion. And then you have potential energy, that's the stored energy, the possibility of motion just waiting to happen. Every moving thing is in a constant dance between these two. And there's no better example of this than a simple pendulum. Think about it. When the pendulum is at the very top of its swing, it stops for a split second. Right there, it's all potential energy. Then, as it swings down, that potential gets converted into kinetic or moving energy. At the very bottom, it's moving its fastest. That's maximum kinetic energy. And as it swings back up, the kinetic energy turns right back into potential. It's just this constant, beautiful trade-off. And potential energy can come in a few different flavors. For instance, when you pull back a bowstring, you're loading it up with elastic potential energy. And that apple hanging on a branch, it has gravitational potential energy just because of its height. Both are just waiting for a chance to become kinetic energy. So we've covered energy in our bodies and our gadgets. But what about the big picture? How do we power entire cities, entire civilizations? Well, we do it by tapping into the massive energy transformations that are already happening all over our planet. And this really breaks it down, doesn't it? We take the light energy shooting out of the sun and turn it into electricity with solar panels. We take the kinetic energy of the wind and capture it with turbines. We even take the stored potential energy of water held back by a dam and convert that into electricity. All our major renewable sources are just us getting clever about hijacking natural energy conversions. But then there's another source, one that's on a whole other level. I'm talking about nuclear energy. This is the mind-boggling amount of energy that's locked away in the nucleus, the very core of an atom.
So here's how we tap into that. Inside a nuclear reactor, scientists unleash that atomic energy. That first transforms into an incredible amount of thermal energy, just a massive amount of heat. Then we use that heat to boil water, create steam, turn turbines, and generate the electrical energy that powers our cities. It's a two-step jump from the tiniest atom to the biggest power grid. So we've followed this thread of energy from a piece of toast all the way to the heart of an atom. Let's pull it all together and talk about why this endless story of transformation is so incredibly important.
If you remember one thing from all of this, let it be this quote: "Nothing is ever static. Energy is always on the move, changing from one form to another. It is a constant, never-ending dance that powers the entire universe."
And that's why this all matters. The better we understand these transformations, the smarter we can be about using them. We can build cars that waste less chemical energy, design power grids that are more efficient, and, most importantly, invent new and sustainable ways to harness all the energy that's already flowing around us. So, I'll leave you with this to chew on. Since energy can't be created or destroyed, only changed, our entire future depends on getting better and better at changing it. So what do you think? What will our next great energy transformation be?